So for quarter 1, week 7, we're going to have estimating the square roots of a number. But before we proceed, let's find the square root of the following. What is the number multiplied by itself is equal to 144? Correct. It's 12. How about the square root of 225? Good job. It is 15. Next, the number multiplied by itself is equal to 400 is 20. How about the square root of 81? And it is 9. Next, the square root of 49. Correct. It is 7. How about the number times itself is equal to 169? Very good. It is 13. The number multiplied by itself equals 361 is 19. How about the square root of 36? Yes, it is 6. And the square root of 64 is equal to 8. So how do we get the estimated square root of a number? So we're going to use this notation. The square root of a n minus a over b minus a, where n is the given radicand, a is the perfect square before the given radicand, and b is the perfect square after the radicand. Let's have the first example. Let's find the estimated root of square root of 18. So again, we're going to use this. So the radicand in the given is 18. So that is our n. Between what two numbers we can find 18? Between what two perfect square numbers can we find 18? Very good. It is between the perfect square numbers, which are 16 and 25. And the perfect square before 18 is 16. And that is our A. The perfect square after our radicand 18 is 25. And that will be our B. So to find the estimated square root, we're going to follow these steps. Step number 1, we're going to write the successive perfect squares, or our A and B. So let's have the given first. We have the square root of 18. And again, A and B are 16 and 25 respectively. For step number 2, we're going to find the square root of A. Our A is equal to 16. The square root of 8 is 4. That will be our whole number. For step number 3, we're going to determine the numerator and denominator of our fraction. For the numerator, we're going to have n minus a. Our n is 18 minus a, which is 16. It is equal to 2, and that will be our numerator. For the denominator, we're going to have b, which is equal to 25, minus a, which is equal to 16, and that is equal to 9. So we already have the whole number, the numerator, and the denominator. We are going to have our mixed number, and that is 4 and 2 nines. So let's convert this mixed number into decimal. So let's divide the numerator by the denominator. So we have 2 divided by 9 and is equal to 0.22. Take note that the decimal should be rounded off to the nearest hundreds. So, we have 4.22. Therefore, the square root of 18 is approximately equal to 4.22. Next, let's have the square root of 55. Again, we're going to use this notation. N is the radicand, A is the perfect square before the radicand, and B is the perfect square after the given radicand. So our N, or the radicand in the given, is 55. While A, or the perfect square before 55, is 49. And the perfect square after the radicand is 64. Let's follow these steps. Let's write the given, and that is square root of 55. And again, the successive perfect squares are 49 and 64. Step number 2, let's find the square root of our A, which is 49, and that is 7. For the numerator, N, which is 55, minus A, which is 49, we're going to have 6. For the denominator, we have 64 minus 49, which is equal to 15. So let's have our mixed number. We have 7 as the whole number and 6 over 15 as our fraction. So we have 7 and 6 over 15. Converting it into decimal, let's divide 6 by 15. And the result is 0.4. So we're going to have 7.40. And that is the estimated square root of 55. Next, how about the square root of 136? So the radicand in the given is 136. Between what two perfect square can we find 136? If your answers are 121 and 144, you're correct. So let's have the given again. And of course, the successive perfect squares. Let's find the square root of our A, which is 121, and that is, okay, it's 11. Let's find the numerator and denominator. So N, 136, minus A, 121, and that is equal to 15. For the denominator, B, 144, minus A, which is 121, and that is equal to 23. Let's form the mixed number. We're going to have 11 and 15 over 23. Converting it into decimals, we have 15 divided by 23. We're going to have this answer. Rounding off the given answer to the nearest hundreds, we're going to have 11.65. Therefore, it is the estimated square root of 136. For our second topic, let's plot irrational numbers on a number line. So how do we plot numbers that are not perfect square? Let's have the first example, the square root of 34. First question, between what two perfect square numbers can we find 34? Correct. It is between the perfect square numbers 25 and 36. So square root of 34 is between 5 and 6, the principal roots of 25 and 36 respectively. And since 34 is closer to 36, it should be closer to 6 than to 5 when you plot it on the number line. So let's have this number line. So as we said a while ago, it should be between these numbers 5 and 6, but it should be closer to 6. So our point will be here. And of course, we should label our answer. Next. How about the square root of 50? Between what two perfect square numbers can we find 50? And it should be 49 and 64. Meaning to say, the square root of 50 is in between 7 and 8. 7 and 8 are the principal roots of 49 and 64. And since 50 is closer to 49, it should be closer to number 7 when you plot it on the number line. So again, the square root of 50 should lie between these numbers, 7 and 8. And it should be closer to 7. So we're going to plot the point here. And of course, again, we must label our answer. And that is the square root of 50. How about the square root of 92? So it lies between the perfect square numbers 81 and 100. Therefore, the square root of 92 should be between 9 and 10. And since 92 is closer to 100, it should be closer to 10 when you plot it on the number line. So again, the square root of 92 should be here between 9 and 10, and it must be closer to 10. And that is the square root of 92.